in prehistoric sedentary societies. The spread of innovations is linked to, just a second, I try to move on. Okay. The spread of innovations is linked to the mobility of ideas, of objects, and of people. I hope you can see my mouse. Yeah, perfect. This can be observed in all prehistoric societies and periods, in sedentary societies as well as mobile societies, even if the specific underlying mechanisms may differ. And if we focus on sedentary societies, what I would like to do today, the most straightforward scenarios of the spatial spread of knowledge and innovation are, on the one hand, migration, which you see down there on the left, defined as irreversible movement of a social group from one area into another, following Roland Preen's definition. And on the other hand, everyday mobility and communication between neighboring or kinship groups within a settlement and beyond. And this is what you see here on the right, which means knowledge transfer without large-scale irreversible mobility. Both scenarios constitute the ends of the scale of mobility, also regarding the distance of movement that incorporates various intermediate forms. If we leave both scenarios aside, the question arises, which other forms of mobility, enhanced information flow, and eventually innovation transfer are there? Taking this question as a starting point today, I want to present two case studies with a focus on the interrelationship between mobility patterns and innovation transfer, the spread of copper metallurgy to Transdanubia in Western Hungary, and the construction of a circular enclosure in the distribution area of the so-called Großgartach culture in southwest Germany in the first half of the 5th millennium BC, where these enclosures constitute rare exceptions. Since, however, mobility as the basic mechanism for the spatial spread of knowledge and innovation is not sufficient for the adoption of the latter, a further aspect has to be taken into account. And this is what you see here on the top right. Social ties based on social intimacy between the communicating individuals constitute another crucial element of innovation transfer. As the sociologist Everett Rogers already stated in his fundamental work on innovation diffusion, social networks play crucial roles in this process, since the adoption of something new or unknown always carries a certain risk. If one cannot evaluate whether the adoption of an innovation is advantageous or not, one will follow somebody who has already tried it and whom one trusts, while general information on an innovation only plays a minor role. Hence, the context of an encounter is also of relevance for the successful transmission of an innovation. In this context, the central question is which forms of mobility in connection with which forms of contact lead to innovation transfer. Next to migration and everyday mobility, a whole range of intermediate forms of mobility is conceivable concerning distances, spatial patterns, timescale agents, as well as reasons. Similarly, different degrees of intensity of social contacts are conceivable. However, before examining both aspects, I would like to make some basic remarks on concepts and definitions of innovation and innovation transfer first. The issue of innovation is not only investigated by social sciences, history, and cultural sciences, but by a broad range of fields, also including economics, for example, or geography, to name but a few. Depending on research topic and field of study, various definitions have been developed. Each field of study emphasizes different aspects. The cultural anthropologist Barnett, for example, defines innovation as any thought, behavior, or thing that is new because it is qualitatively different from existing forms. He emphasizes the importance of reorganization instead of a quantitative variation as criterion for novelty. The sociologist Everett Rogers describes innovation as any idea, practice, or object that is perceived as new, which emphasizes the perception of novelty and thus the emic perspective. For my talk today, I would like to consider Renfrew's definition, and he says invention is the discovery or achievement by an individual of a new process or form, whether deliberately or by chance, and innovation implies the widespread adoption of a new process or form, and clearly it must be preceded by the relevant inventions, whether by a short or by a long period. Innovation transfer is described by Everett Rogers in one of his books on this topic, diffusion of innovations. And he says innovation transfer is based on communication, and it is a process by which an innovation is communicated through certain channels over time among the members of a social system. And so you see we have 4 crucial elements for innovation transfer according to Rogers: the innovation itself, communication channels, time, and a social system. But I would like to put it in other words, because we are looking on archaeological sources, and therefore I would like to suggest a different definition. And I would define innovation transfer as consisting of 2 crucial elements: information flow plus adoption of the innovation, which means acceptance, implementation, or sometimes you can also say, or you often read, appropriation of the innovation. And this is what is shown on the next slide. Here you have the information flow plus the adoption or implementation of the innovation, and this makes the innovation transfer. And both elements are influenced by various variables, which are also partly documented in the archaeological record. And this is why I chose this way of defining innovation transfer. Information flow, for example, is dependent on population or settlement density and cultural connectivity, on social ties and mobility, to name but a few. And adoption or implementation is dependent on human agency, subsistence strategies, social structure, system of values, to name the most important. I'm well aware that this small set of variables cannot completely describe innovation transfer, but I think this is a possibility or a medium or a way of looking at innovation transfer to get a better understanding of what's going on. Okay, and today we will look on mobility, and this will be the focus of my talk. And as I already mentioned in the beginning, mobility as the basic mechanism for the spatial spread of knowledge and innovation is not sufficient for the adoption of the latter. A further aspect has to be taken into account: the social ties I mentioned already, and social intimacy between the communicating individuals. And this is what Gilbert Tostevin already was discussing in one of his papers. His focus was on contacts and potential knowledge transfer between anatomically modern humans and Neanderthals. And his basic idea is that similarities in flint tool production hint at contact events of a certain intensity, since specific technological steps cannot be reproduced by watching them in a short one-time encounter. One of his central considerations is that not each kind of contact leads to knowledge transfer and to acculturation. Random contact events between strangers in the periphery of the range of a forager group probably did not lead to knowledge transfer. And this is what you see here on the left: contact along the pathways, which is socially distant. Instead, they might even be characterized as hostile or competitive events. In contrast, and this is what you see here on the right, the probability of knowledge transfer is much higher during encounters within the encampment as the residential heart of a group, because the contact there is socially intimate. And this is also true for sedentary societies. It is highly probable that short encounters between strangers did not enhance innovation transfer. Rather, a certain degree of social intimacy was necessary that only developed either during repeated or during longer contacts. Within sedentary societies, this kind of contact existed between neighbors and probably also between kinship groups, but the diffusion of certain innovations in the archaeological record indicates that these socially intimate contacts also existed over longer distances, requiring a certain degree of mobility. The question that arises is what kind of mobility patterns in sedentary societies lead to intensified contacts, and as such produce contexts in which the application of a specific innovation can be observed and learned while at the same time a certain spatial distance is covered. And this is what I want to show you in this table. This table summarizes a survey of archaeological literature on mobility patterns and contact events in prehistoric sedentary societies with a focus on Neolithic and Copper Age. And it's complemented by theoretical thoughts and knowledge transmission and innovation transfer. The results of my survey produced a collection of various scenarios, all constituting more or less well-attested interpretative models of the archaeological record. Next to isotope analysis of human and animal bones, which is not the focus of my talk today, the discovery of exotic objects that are alien to the local and regional context forms an important basis for these scenarios. Next to distance, these models also consider the nature of contacts and communication. Thereby, they form a useful basis for developing a notion of how innovation transfer could have worked. And I will quickly guide you through this table. And the first line you see down the line, exchange networks, and we have evidence from lithic raw material, particularly where these down the line exchange networks cover distances of up to 500 kilometers. And when we look at the characteristics of the contact events, is what we have with down the line exchange networks, we have small scale and short-term mobility, but it's a regular basis we have when people meet. And therefore, I would assume that the degree of social intimacy in down the line exchange networks is high to very high. And the same goes for identity groups like kinship networks or neighborly networks or other alliances of close spatial proximity. Hans-Peter Wotzka has looked at 40 Neolithic cultures and 160 ethnic groups documented in the anthropological literature in order to identify the spatial range of social identity groups. And his analysis showed that they mostly cover an area of 500 square kilometers maximum, which is not very large. It's about 20 to 25 kilometers when you take a square. So it's small scale and short-term mobility here in these identity groups or in these kinship networks and neighborly networks. But you have regular contact events on maybe an everyday basis. So I would assume in these networks, the degree of social intimacy is also very high to very high. Then we have directional exchange. In the sense of a transfer of certain goods from its source to a specific place. And this can produce a spatial pattern that leads to high amounts of this good in quite distant places, while from sites in between only minor amounts or no goods at all are documented. Renfrew has provided this definition and relates this definition to exchange mechanisms in the Mediterranean Bronze Age, but we also have examples from Neolithic contexts in Central or Eastern Europe, for example. Directional exchange can be characterized as covering long distances in a direct way. We have examples of 200 to 250 kilometers. And although contact events probably took place infrequently, the length of stay and thus the time span of contact were not necessarily of short duration. Moreover, as the archaeological record shows, these journeys were undertaken over generations, which means repeatedly, maybe even once a year. And therefore, the communicating parties were not foreign to each other, and their relationship was based on a certain level of confidence, or they knew each other very, very well. And therefore, I would also assume that the degree of social intimacy was high to very high. Then we have prestige chain exchange or elite networks. This is what Renfrew defined also in the 1970s. We have specific objects in the Neolithic and Copper Age in Europe that often are interpreted as prestige goods, like copper heavy tools or jadeite X blades or spondylus, for example. And they can cover enormous distances. Alpine jadeite X blades, for example, have been documented at a distance of over 1,500 kilometers from their source. And for spondylus, we even have distances of 2,000 kilometers. In order to explain the underlying exchange mechanisms, Renfrew proposed the so-called prestige chain model that describes the exchange of prestige goods between high-status individuals on the basis of gift exchange. The objects, things that were not used in daily activities, were passed on in successive stages and were usually deposited in burials or deposits. As according to Renfro, these objects were passed on to more distant persons than those in the next village. The effective spacing of participants in the network is wider, according to Renfro. Therefore, this scenario describes contacts over long distances with infrequent transient contact events. Okay, and there I would also assume that the degree of social intimacy was high to very high between those persons that participated in these networks. Then we have exogamy, and the typical archaeological record for building these scenarios are burials, which exhibit grave goods that are exotic in their local and regional context, but as a whole set are known from neighboring or even distant regions. And we have examples from Bronze Age Europe, for example. And what we think is that they reflect marriage partner mobility. And we see that they cover distances of up to 200 kilometers and sometimes even more. Knowledge transmission and innovation transfer related to this irreversible migration of individuals in the context of exogamy is hard to evaluate. Intensity of contact and social intimacy are naturally very high. However, the question arises as to whether the social circumstances produce a different effect. This would mean that an individual moving into a group where he or she will spend the rest of his or her life adapts to the group rather than bringing in innovative practices or ideas. In this case, knowledge transmission and innovation transfer would be far less extensive than one might expect. But so far, there have been no investigations that would allow for more detailed conclusions at the moment. And then I have two other examples, transhumance and supra-regional conventions. Transhumance can also be regarded as a type of mobility that generates contact events which enable innovation transfer. For example, when herders with their herds meet in a specific place and stay there for a longer period of time. Detailed information on distances that were covered by transhumans or more mobile ways of livestock herding are scarce, however. We have some recent examples, for example, from Spain, where we see that they cover distances of 20 kilometers a day, but it always depends on local and regional conditions and therefore are probably very variable. So we cannot say, so we have no data that is representative, so we cannot say which maximum distance was covered by transhumans. But I would expect a seasonal to long-term mobility with infrequent contacts. So maybe the degree of social intimacy was rather low, but that's really a theoretically constructed example at the moment. So I have no data at the moment to discuss this example more detailed. Another idea is that supra-regional conventions also enhanced innovation transfer. And we have examples from enclosures in Central Europe, for example, where we see that individuals covered more than 100 kilometers to get to these enclosures. And since these are organized contact events, I would assume that the degree of social intimacy was high to very high. Based on these insights, I'd like to present two case studies to illustrate the interrelationship between mobility patterns, social ties, as well as social intimacy and innovation transfer. And first, the focus will be on the construction of a circular enclosure, which you see here on the left, in the distribution area of the so-called Großgartach culture. The so-called roundels or circular enclosures were built during a limited period of time in the first half of the 5th millennium BC in Central Europe. They are mainly found in the distribution area of the Lengyel culture, which you see here along the Danube, and the stroke-ornamented pottery culture, which you see up there. In contrast, this type of enclosure was not common in the so-called Großgartach culture, which is here distributed or located in the southwest of Germany. So far, only 4 enclosures of this kind have been detected in the context of this archaeological culture, and one of those is Ippesheim here in northwestern Bavaria. The roundel of Ippesheim, and here you see an idealized reconstruction of this roundel, was constructed on the fertile soils south of the River Main, an area densely settled during the early and middle Neolithic in the first half of the 5th millennium BC. The roundel dates to around 4800 BC and was situated in the eastern periphery of the Großgartach culture, which you can see here on the map. The neighboring cultures in the east and the northeast here and the southeast there are the stroke ornamented pottery culture, and here in Bavaria it's the so-called Southeast Bavarian Middle Neolithic, where these enclosures were common. Since we hardly know any roundels from Großgartach contexts, it seems likely that the idea to build this enclosure came from these neighboring cultures. The roundel of Ippesheim was detected in the 1980s by aerial archaeology and excavated in the 1990s and up until 2003. In 2010, together with my students, I excavated parts of the neighboring settlement. And in the following years, together with a colleague, I did a geomagnetic survey in the settlement area. Therefore, we have detailed information on the ditch, and this is what you see here. And we can even discern several phases of the ditch. We have detailed information on the gates, here number 1, 2, 3, 4, 5, and 6, and partly also the surrounding areas. As an analysis of the orientation of all gates by the astrophysicist Schmidt-Kahler shows, 3 gates, and this is what you see here, exhibit an interrelation with solar events. The northeastern gate, this one here, was oriented towards sunrise during summer solstice. The southeastern gate towards sunrise at winter solstice, and the western gate towards sunset at equinox. Moreover, these orientations integrate the surrounding landscape, since from the center of the roundel, and this is what you see here with the black point here, and from the center of the roundel, it was possible to observe these astronomic events that then lined up with prominent mountains here in the vicinity. So sunrise during summer solstice was visible from the center of the roundel behind this Bullenheimer Berg, this hill here, northeast of the roundel, and sunrise during winter solstice was visible behind the Kapellberg, which is also in the vicinity of the roundel. So what we can see is that the whole enclosure was perfectly fitted into the landscape, which in turn required really special knowledge. And it seems natural to assume that this knowledge came from those regions where the construction of roundels was part of the cultural knowledge, which is the SOB culture in Southeast Bavaria, where the nearest examples of this type of enclosures can be found. And this is also indicated by the results of the geomagnetic survey of the Ippesheim site. Here, down there, you see the roundel of Ippesheim, and here you see the settlement pits surrounding the roundel. And what you can also see here is another ditch that surrounds most parts of the settlement pits. And here you see further ditches or segments of ditches surrounding the roundel of Ippesheim. And we also did a small-scale excavation here, and what the excavation showed is that the structure also dates to the first half of the 5th millennium BC. So we assume that all these structures existed at the same time. Interestingly, most of the circular enclosures we know so far do not exhibit this architectural feature. So far, there's only one region where this element has been discovered, and this is Southeast Bavaria. And this is what you see on this map. Here you have the roundel of Ippesheim, which I showed you before, and down there you have various roundels in Southeast Bavaria. The gray spots are roundels without these surrounding ditches, and the red dots are roundels with these surrounding ditches, and this is what you see here. Here, for example, you have a single ditch. Here in Schmiedow, you have two parallel ditches here in Künzing-Unterberg and in Koting-Eichendorf. You have really a complex system of ditches. And this indicates for me direct contacts between both areas that finally triggered innovation transfer, either by knowledge transfer or by the arrival of specialists from Southeast Bavaria who helped to construct the roundel in Ippesheim. This insight allows for a more detailed analysis of knowledge and innovation transfer between those areas lying up to 200 kilometers apart, linear distance. If we look at the archaeological record in both regions, various finds hint at contacts between the two. First of all, the so-called Anhofen chart, which you see here on the left, which was mined in the eponymous mine in southeast Bavaria, down here at the Danube, and here is the site of Ippesheim, here's the flint mine, was found in considerable quantities in northwestern Bavaria, including Ippesheim. As quantitative analysis showed, this raw material was distributed via directional exchange networks. On the left, you can see the model of Colin Renfrew for directional exchange, and on the right, you see the results of a dissertation by Georg Roth on the distribution of Anhofen chart towards northwest, which also covers the area of Ippesheim. And here you see the flint mine of Anhofen, where you have 100% Anhofen chart, and after about 20 to 30 kilometers, the amount of Anhofen drops to almost zero, and in a distance of 100 to 150 kilometers, the amount increases again. And here you see the site of Ippesheim. It's about 170 kilometers from the flint mine, and here we have an amount of 50% of Anhofen chart. The interesting thing is that we have also other lithic raw materials at Ippesheim, but all other raw materials documented there were distributed via down-the-line exchange networks. This is what I was looking at in my PhD thesis. Consequently, it is only the exchange network towards Southeast Bavaria, the exchange network of the Anhofen chart, that indicates direct contacts between both regions. Further evidence for direct contacts between Ippesheim and Southeast Bavaria comes from pottery. At Ippesheim, various sherds with Southeast Bavarian SBK or SOB decoration were documented, which you can see here on the left. This pottery was presumably not handed on in a down-the-line exchange system, but rather reflects direct contacts too. Moreover, several sherds with hybrid decoration were found, and this is what you can see here on the right. They exhibit SBK decoration, which was partly accomplished in a local Großgartach-like manner. And these shirts might have been decorated by individuals who had been socialized in the distribution area of the Southeast Bavarian pottery before they moved to Ippesheim, where they tried to produce Großgartach pottery. This is one hypothesis. And one explanation for this finding would be exogamy, which means marriage partners moved from Southeast Bavaria to Ippesheim. In sum, the construction of the circular enclosure at Ippesheim reflects a direct knowledge transmission and innovation transfer from Southeast Bavaria to Ippesheim. These contacts are substantiated by the analysis of lithic exchange systems and the finds of imported pottery, the latter maybe even reflecting the presence of marriage partners from Southeast Bavaria. Both types of mobility and social ties, directional exchange networks, and exogamy presumably triggered or at least facilitated this innovation transfer via direct contacts over 170 kilometers. The second case study is the spread of copper metallurgy to Trans-Danubia in the 5th millennium BC. Here on the left, you see one of those copper heavy tools, which actually comes from Southeast Europe and moved to the northwest. So far, here you see a map of the so-called Lengyel culture, which was located in Trans-Danubia, and this is where my focus is on now. So far, the earliest evidence for the pyrotechnological working of copper in Europe comes from the site of Bjelovar in Serbia, south of Trans-Danubia here. There, in a settlement of the Vinča culture, pieces of slag were found in a depression together with several thousand ceramic sherds dating to about 5000 BC. In the following centuries, the spread of early copper artifacts and technological knowledge of their production is documented. In southeast Hungary, and here you see a map of Hungary, here you see the Danube and the Tisza River. And in southeast Hungary, first evidence for copper artifacts and evidence for copper working date to the first half of the 5th millennium BC. East of the river Tisza, and this is the area you see here. Here you see tell settlements of the first half of the 5th millennium BC. And here you see the green diamonds, which represent copper artifacts, and the large diamonds represent more than 20 copper artifacts, and the smaller ones more than 10 and more than 5, and so on. East of the river Tisza, the copper is documented in the form of ornaments and small implements, for example, in burials of various cemeteries and also in tell settlements. And sometimes even crucibles and pieces of slags were found. West of the Danube, and this is what you see here, in the area settled by the Lengyel culture, copper finds show a remarkable distribution pattern. And this is what you see here on the left. Most copper finds, like ornaments and small implements, were recovered in the settlements and cemeteries here in the southeast of Transdanubia. In contrast, in the northwestern distribution area of the Lengyel culture, we have only 3 sites with copper artifacts known so far, and this is what you see here. West of the Vienna Basin, in this area, first evidence for copper artifacts dates to the second half of the 5th millennium BC. So what we see here is a temporary border in Transdanubia where the spread of copper metallurgy stopped for several centuries. And this is where the border runs through. And the interesting thing is that the border runs through the distribution area of the Lengyel culture. To the east, we have a transfer of knowledge of copper working and the use of copper. And in the northwest, we have almost no copper at all. And this is what I want to look a bit closer now. As stated at the beginning of my talk, the information flow is influenced by demographic aspects, mobility, and social ties. It can be analyzed by looking at exchange networks. And this is what I would like to do here. Here you see a study by Katalin Kovac, who investigated the exchange networks of various lithic raw materials, marine mollusks, and copper in Hungary during the first half of the 5th millennium BC. And as her analysis shows, this is what you see here on the map, these networks separated both areas, since southeastern Transdanubia was closely connected to the networks here in the east, where we also have the copper finds and the tell settlements, while the northwestern part of Transdanubia, the northwestern part of the Lengyel culture, is not connected to this area, but is connected to the northern area here of East Hungary and further to the north. And copper comes from here, from the south. So my idea is that we have exchange networks that connect southeast Transdanubia and the southeastern area of the Lengyel culture to the areas where we have the copper artifacts, but there is no connection to the northwestern part of the Lengyel culture. And there are further differences that have to be stressed. While the Lengyel settlements in the southeastern part of Transdanubia can be characterized as extensive flat sites with areas of 25 hectares, like at Assot, for example, the settlements here in the northwestern part of the Lengyel area are quite small and we have a very dispersed settlements. The same goes for burials. While we have huge cemeteries here in the southeastern part of Transdanubia, we have only a small number of single burials within the settlements of the northwestern Lengyel culture. Therefore, we have low population densities here in the northwest and high population densities in the southeast, and we have an information flow that obviously does not work in the first half of the 5th millennium BC. while the absence of exchange networks or communication networks in a wider sense presumably impeded the innovation transfer to northwestern Transdanubia, the lithic exchange networks in southeastern Transdanubia and the Great Hungarian Plain can explain the spread of copper metallurgy to those regions here. Kovacs reconstructs a down-the-line exchange network for some lithic raw materials that could have formed the basis for knowledge transfer and information flow. In this case, the innovation transfer would have proceeded via small-scale and short-term mobility, facilitating regular temporary contact events based on a high degree of social intimacy. And now this is my last slide. What I just want to sum up, the case studies I presented facilitate developing a first notion of how innovation transfer could have worked in a concrete case by identifying traces of information flow in the archaeological record. Moreover, they give an idea of the role of mobility and social ties played in these processes. It becomes clear that mobility alone is not enough for the diffusion of an innovation. Rather, social ties between the communicating parties are a crucial precondition for acceptance and implementation of innovation. While we would expect strong social ties between neighboring and kinship groups in prehistoric contexts, the case of Ippesheim showed that direct contacts existed over enormous distances of up to 200 kilometers, forming the basis for knowledge and innovation transfer. Although the data collection is far from being complete, this gives a first idea of how far mobility and knowledge transfer can reach or cannot reach. Further data collection will help to substantiate these first insights into distances, mobility patterns, social ties, and innovation. Thank you very much for your attention.